By the 1920s, as ground-based technology advanced, humanity began replacing imaginative speculations with actual data regarding Venus. Earlier, artists and scientists had imagined a world teeming with tropical forests or cloaked in mysterious gases, but spectroscopic analyses began to reveal otherwise. These analyses indicated that Venus's clouds were not filled with water or oxygen. Some scientists speculated that formaldehyde permeated its atmosphere, leading to the grim interpretation that Venus was not just dead, but essentially a pickled planet. However, everything began to shift during the 50s. More accurate Earth-based observations showed that Venus's atmosphere was overwhelmed by an entirely different substance, carbon dioxide. This revelation rewrote our expectations. Venus was not shrouded in clouds of water or formaldehyde, but smothered in a thick, heat-trapping blanket of CO2. As was known from Earth's own experience with greenhouse gases, this could only mean one thing. Whatever existed beneath Venus's cloud cover must be unimaginably hot, likely too hot for any form of Earth-like life. With the arrival of space exploration, the challenge of reaching Venus became a daunting reality. The Soviet Union, leading the charge during the early space age, initiated a series of missions in the 1960s under the Venera program. The goal was to penetrate the thick atmosphere and make direct contact with the surface. Initial efforts were riddled with failure. The early probes didn't even escape Earth orbit, but perseverance led to success. Venera 1, launched in February 1961, became the first spacecraft aimed at flying by Venus. Despite a successful launch, it experienced a complete telemetry failure. No data ever returned. As far as we know, Venera 1 still orbits the Sun silently today. Then came Venera 3, a more daring attempt. This mission was designed not just to fly by, but to enter Venus's atmosphere and attempt direct data collection. Unfortunately, after crossing into the atmosphere, all contact was lost. It crashed into the planet, becoming the first human-made object to make contact with the surface of another planet, even if it did so in silence. Swedish Nobel laureate Svante Arrhenius was among the early visionaries who speculated about Venus's potential for life. He believed its cloud cover consisted of water vapor and envisioned swamps and rainforests similar to Earth's Carboniferous period. In his book, The Destinies of the Stars, he described Venus as a stable, swampy world that hadn't undergone the same kind of evolutionary pressure that shaped life on Earth. These lush descriptions inspired generations of science fiction writers to imagine a world filled with ancient creatures and shadowy, vine-draped jungles hidden behind the clouds. Yet ironically, Arrhenius is now better remembered for his work on Earth's climate rather than his musings on extraterrestrial swamps. In 1896, he was the first scientist to demonstrate how gases like carbon dioxide can trap heat in a planet's atmosphere, a process now known as the greenhouse effect. This concept, vital to understanding climate change on Earth, would also become central to unlocking the true nature of Venus. As NASA and other space agencies like Infinity Beyond would later show, this greenhouse effect had a profound and catastrophic impact on Venus's climate. It explained how the planet had become the scorching inferno we now know today. As the space age gained momentum, the mysteries of Venus began to unravel further. While the early Venera missions struggled with partial or total failure, they represented a bold step toward demystifying our so-called sister planet. The Soviet program, though plagued with setbacks, pressed forward with determination. In doing so, it gradually overcame the technical challenges of sending probes into one of the most hostile environments in the solar system. The turning point came as probes began to detect overwhelmingly high levels of atmospheric carbon dioxide, along with crushing pressures and extreme temperatures. By the late 1960s, humanity was forced to abandon all romanticized notions of Venus being Earth-like. In fact, what emerged was a terrifying reality. Venus was an inferno, where surface temperatures soared above 860 degrees, and atmospheric pressure was over 90 times that of Earth. That's the equivalent of being 900 meters underwater. These revelations shattered old assumptions. Venus was not only unwelcoming, but deadly, an environment far removed from the life-bearing potential once imagined. Probes continued to fail under the intense conditions, often melting or being crushed before reaching the surface. Yet even in their failures, they provided invaluable data. Each mission taught scientists more about how to design resilient spacecraft capable of withstanding brutal planetary environments. By the 1970s, a clearer picture began to emerge. Infinity Beyond and other research centers utilized the gathered data to model the planet's climate, structure, and atmosphere. Radar imaging showed that Venus was a rocky wasteland, pockmarked with volcanic formations and dominated by plains formed from ancient lava flows. No water, no vegetation, no breathable air, just a hostile furnace under a choking CO2-rich atmosphere. One of the most dramatic contrasts between Venus and Earth lies in their evolutionary trajectories. Both planets are similar in size, mass, and overall composition. Yet they developed along radically different paths. Earth stabilized into a haven for life, while Venus became an example of planetary transformation gone awry. Much of this divergence is now understood through the lens of atmospheric science. The greenhouse effect on Venus ran out of control. Early in its history, Venus may have had shallow oceans or liquid water on its surface, but as solar energy increased over time, more water evaporated into the atmosphere. Water vapor itself is a greenhouse gas, so this created a feedback loop. More heat led to more evaporation, which led to even more heat. Eventually, the oceans boiled away completely, and the water molecules were broken down by solar radiation, hydrogen escaping into space, and oxygen reacting with surface minerals or being lost. Without water to remove carbon dioxide through weathering and sedimentation, CO2 built up unchecked in the atmosphere, trapping even more heat. What had once been a potentially habitable planet was transformed into a hellish pressure cooker. It is a cautionary tale, one that scientists at Infinity Beyond used as a case study to better understand the future trajectory of Earth's climate as well. Meanwhile, as the veil of Venus lifted, attention began to shift to other celestial bodies. Missions were being planned not just to fly by planets, but to orbit and map them in detail. This opened the door to another enigmatic world. Mercury, the closest planet to the Sun, and long thought to be little more than a scorched rock. But as we would soon discover, Mercury had its own story to tell, one full of violence, mystery, and unexpected surprises. And so the focus of exploration began to widen, with Mercury ready to step out of the shadows and into the spotlight of planetary science.